Okay, so on this question, they're telling us suppose the age that children learn to walk is normally distributed with mean 11 months, standard deviation 1.3 months. Six randomly selected people were asked what age they learned to walk. Round all answers 4 decimals. Okay. They say, what's the distribution of X? Okay, here's the first thing to know that X, whenever they have X, that's for one person or item or whatever. And when they have X bar, like on part B, X bar, that's the average for a group size N. So it's like if I said, hey, what did you get on the last exam? That's one person versus what was the average for the class on the last exam? So X bar is always the average of a group. Regular X is just one person. Okay. So coming up here, then they're going to want the mean and the standard deviation. That's what those two boxes always are. So what's the mean? Well, they told us the mean is 11 months. So the average child walks at 11 months. Standard deviation, not everybody does the same thing. Standard deviation 1.3 months. Okay. And now down here, same thing, mean, right? You see it's 11, 1.3, 11. But then this is different. Why? Well, what it is it's in the notes here. Let me show you the notes. Whenever this is the notes to help with this stuff. So standard deviation, if the question is only for one person or item, enter standard deviation without adjustment. If the question is for a group of size n, enter as standard deviation divided by the root of n. It's going to change the standard deviation. So this is going to be 1.3 divided by the square root of n. What is n? It's 6. N equals 6. It's the group size. So how many people in your study? Divided by the square root of 6. And what you'll get is this number right here. So there is the standard deviation. I can show you 1.3 divided by the square root of 6. Just go to the calculator. Here I am. Not here. Where am I? Here I am at the calculator. Down here, let me clear this. What was it? I forgot already. It's a 1.3 divided by the square root of 6. 1.3 divided by the square root of 6. So you just go, the scientific calculator that's at the bottom of any of these calculators. You see the scientific there. 1.3 divided by square root of 6. There it is. 0.5307. That's how we got that. 0.5307. Okay. So now let's go on. What is the probability that one randomly selected person learned to walk when the person was between 9.5 and 12.5 months old? Okay. How do we put things in the calculator? Well, here it is. Again, here's the notes. Here's a picture of what the calculator is going to look like. And basically, it's just telling us what the things are. Probability. This is only for percentage or decimal probability values. Convert to decimal before you enter in the calculator. P of X, this is for regular numbers, not percentage or probability numbers. We know what the mean is. We know what the standard deviation is. Okay, so let's go to it. So let's say, what's the probability that one randomly selected person? So what is the probability? So when I come up here, I'm going to say, okay. I'm going to say, it's going to ask me P of X. This is what the calculator is going to do. And it's going to say, I'm going to choose the between option because it says between 9 and the 9.5 will go here. Kind of scribbling this out. How's it going to look in the calculator? Oh, it's right. Yeah, the P of X is just right there and the between's below. Okay. I guess that is how it is. The P of X is right here. And the between's just down here a little bit. Between, and then you put the 9.5 on this side and the 1.5 on that side. And then below that, it's going to say mean on the calculator, standard deviation, and probability. So what is the mean? We know that the mean is 11, right? The average child walks at 11 months. Standard deviation. Now, which standard deviation do I use? Well, see, it says 1. So I'm going to use one person, the top one, just the regular standard deviation, no adjustment, 1.3. The probability, you just leave that probability blank, right? Because you always leave one blank, hit the buttons on the calculator. All right, let's go. Let's go do it. 9.5 and 12.5. So I'll go to the calculator. I'll show you exactly how it works. So let's go to the calculator and try that. So to the calculator we go. So I'm going to choose the between. And what is it? I got to clear out. I got some other old value I was putting in. Was it 9.5 and 12.5? I think that was it. So I'm going to go 9.5 and 12.5. Let me double check. Is that what it was? Yeah, 9.5. Between 9.5 and 12.5, put in 11 and 1.3. So back to it. Put in 11 for the mean and 1.3 for the standard deviation. Um, and then the probability, we're gonna now you gotta leave that blank. If you have a number in there, watch this. When you hit the calculate, it's gonna go, no, 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 leave one in blank. So you gotta leave that probability blank and then hit calculate. And it'll fill it in. There it is. 0.7514. It filled it in for us. 0.7514. There it is. We got our probability. Now, now we go on from here. And the next question says, for six people, find the probability that the average age that they learn to walk is between 9.5 and 12.5 months old. We think, isn't that the same question? It's between 9.5 months and 12.5 months? Almost. But notice it's for six people now. You underline that. Six people, not one. This was one person. So six people now. So it's going to be about the same. You're still going to do the P of X and the between. And when you do the between, you're going to say, 9.5, 12.5. And so do that. And then the mean, I didn't spell that right. Mean standard probability. So what's the mean? Same thing, 11, average person, child walks 11 months. Now, what about standard deviation? I'm going to use this one, 0.5307. 0.5307 because it's a group now. Remember, this is six people. Use the new standard deviation. Probably leave that blank. Let's go back. So we really just need to change this number, 0.5307, huh? Let's go back, change the standard deviation to 0.5307, 0.5307. Now you got to make the probability blank. Again, you got to have a blank so I can fill in the answer for you. Get rid of that, then calculate. There, 99529. 99529. 9952, there we go, or 53, it would take either one. There we go for that answer. Now, part E says, for part D, is the assumption that the distribution is normal necessary? The answer is yes. What are they talking about? Well, that's up here in the notes. If you look at the notes, it says when you have less than 30, when the number in your group is less than 30, we must be told the data is normally distributed to use these formulas. The assumption of normal data is needed, right? You were using a normal probability calculator. We've got to know that the data is normally distributed. Remember, not everything in life is bell-shaped, normally distributed. Some things, most things are. That's why it's called normal. But anyway, if they've got to tell you it's normally distributed if you have less 30. But if you have a really big group, greater than 30, your group is like 35, 40, 50, 100, the number of the data values is so many that the data will automatically make a bell curve. So we do not need to be told this. The assumption of normal data is not needed in that case. So they're just saying, hey, so what was R in? R in up here is 6. So that's less than 30. So yes, we do need to be told. And they did. They said, it's normally distributed, right? The age at which children first learn to walk is bell-shaped, normally distributed. We did need to be told. If we were doing a group of kiddos more than 30, we wouldn't even need to be told this. It would automatically make a bell. That's what that's saying. All right, let's get to the last question. Question here. Q1, what's that? Those are quartiles. Remember? Remember, it's a ranking system from 0 to 100%, with 50 in the middle. Right here would be 25%, which is Q1. And this is 75%, which is Q3. It's a ranking system from 0 to 100, like a football game, basketball game. This is the end of the first quarter. So they're saying, if you're going to take these kiddos and talk about what age they first walk at, what would be the 25% that you say, hey, my child walked, early at the 25, meaning what does that mean? Only 25%, when your child walks, they can do that as a percentile. When your child walks, 25% of the kiddos walked earlier than your child walked, and 75% walked later. That's the point. If your child's at the Q1 mark, then your child walked pretty early, earlier than most children walk. 75% of them walk later. If your child's at the 75 percentile, then 75% of the children walk earlier than your child walked, 25% walk later, right? You get the idea. That's percentile. So Q1 is that. So what are we going to do on the calculator? Well, again, the calculator for the P of X we have up here, and we have the mean, standard deviation, and the probability down here. So the question is, what do we do with Q1? That's a probability number, right? That goes down here, not up in P of X. How do we know? It says right here in the notes, probability, this is only for percentage or decimal probability values. And P of X, this is just regular numbers, not percentage probability. So yeah, Q1's a percentage probability. That goes right there, 25%. And then put in the mean, which is what, 11 months. And standard, now which standard deviation? We'll see it with group of six. So I'm going to use this group one, 0.5307. Got to keep using the group one because we're talking about a group. So we use the group standard deviation there. Okay, put that in. And oh yeah, for P of X now, what are we going to do? We're going to choose less than what? Because 25% or less than, that's what it means to be at the Q1, right? If I'm watching a basketball game, 25% of the game is past, is in my past, is to the left, is less, right? If your child is walking at the 25 percentile mark, or a group of six children have an average that's at the 25 percentile mark, that means 25% of the children walk less earlier, less. So do that, leave a blank here, and hit the buttons on the calculator. Let's go there. 11. I just got to change probability to 0.25 and erase the top thing. So change this to 0.25. 0.25. And then this has got to be up here. Choose less and get rid of that value. See what I did there? See, I'm choosing up here, greater, less. I chose less. Whoops, I didn't do this very well, did I? 0.25, there we go. And everything else is right. Calculate. Got 10, see the number of the period up there in the top? 10.6420. 10.6420. 10.642, that's right. What about the Q3? That's easy. Just change this to 0.75 because Q3 is 0.75. Let's go back, change it to 0.75. And oh, we got to erase this old answer up here. Remember, because you got to have a blank and hit calculate. Boom, 11.358, 11.358 when it's rounded. 11.358. There we go. Final step. We got to get IQR. What's IQR? That's easy. That's just Q3 minus Q. That stands for interquartile range. Subtract the two quartiles. Just hit the buttons on your calculator. You'll get that answer. And so there we go.